Finally, with the handshake completed, the TLS client and server are able to communicate. Every packet that is sent in this communication is going to be in the TCP transport. And all of this data starting from TLS is from the TCP perspective, part of the message data. But now we have this extra layer. There's a TLS header, which tells us what step of the protocol we're in, and then the data that goes with that, that's being sent from the client to the server or vice versa. The client is going to use its encrypt key, and the server is going to use its encrypt key for anything that it sends. And it sends not just the plain text, but to ensure integrity, it sends a MAC of that plain text as well, computing with an HMAC using the key that the client uses for computing a MAC to send to the server, or vice versa for the server. This MAC is actually not computed just over the plain text, but also the plain text plus a sequence number. And this sequence number added to the plain text protects against missing packets in the TLS protocol. Of course, this is running over TCP, and TCP normally takes care of reordered or missing packets for you, but if someone is trying to break into your communication, then they might synthesize wrong TCP packets, and we need to make sure that at the data level here, we are guarding against that. The sequence number takes care of that potential problem. Notice that I wrote EncCBC here because we're doing some sort of block cipher probably, but we need to have a mode of operation in that case, and this would again be picked by the cipher suite choices that the client offered and the server picked. So a typical choice is some encryption with cipher block chaining. If we do that, then that's where the key is being used, and that again gives us a certain amount of protection against missing or reordered packets. Just as an example of what this looks like in Java, if you're not using TLS, but if you're using just the raw facilities underneath, then you can select the cipher suite that we're illustrating in these pictures as AES for the block cipher, CBC for the mode of operation, and PKCS specifies what form of padding is used to make all of the plain text messages the right size for that block cipher. And then that cipher, after you get an instance, you have to initialize it with a suitable key and initialization vector that was derived in the case of TLS from the master secret.